proving the Earth is stationary, Red?
I'm actually concerned here. Do you know what a gimbal is?
Okay, I'm talking about the base of a
word gimbal. What does the word
that's
gimbal
what they're called. I don't know what gimbal you're talking about, but a gyroscope base. Hey, Red, I just want to know why a gimbal base, which is the mount for a gyroscope, doesn't spin with the spin of the Earth, just like you're alleging this Foucault pendulum is causing all this movement because of the spin of the Earth. I just want to know how come that instrument that you have to manually start and stops during eclipses the only experiment that shows movement. Why can't you put a gyroscope on a table and witness the movement of the Earth?
Oh boy. Okay, so just to make sure we're clear, you said gimbal base, right? What does a gimbal base?
The base of a gyroscope.
The base of a gyroscope. Okay, the reason
around the gyroscope.
Because
so,
it's the base. That's because it's the base. If you're asking, does the gyroscope itself actually move around? That's why I wanted you to elaborate, but you didn't make that correction, so I'll make it for you. The gyroscope actually does move around. It's just that you need a sensitive enough gyroscope to actually achieve that. And in fact, you can actually get them, and that observation has been done. And to show that, I have to find the paper that I was actually given. I don't have it on me just yet, but at the very end of this, I will send it to Steve and Kyle to put in the description of this debate. But to answer your question directly, it has been observed multiple times, and it's just that the pendulum is just a very easy and relatively cheap way of doing it that results that we are in fact moving, and that it is dependent on your position on the Earth.
Shows the results you want. Got it.
We have no influence over the results. It swings the way it swings, and no one's been touching it since.
So you haven't explained the Elias effect, but also if you could touch on the north, and since you claim there's a southern pole star, how that Earth going 66,000 miles an hour around the sun, and the sun going 450,000 miles an hour through the Milky Way, and then the Milky Way is also purported to move, somewhere between 300,000 and 1.5 million miles. I'm just wondering how we get stationary stars because of all that movement.
The reason we get
well, let's make that the last question, because that actually was from the live feed as well, and I'll address it to Reds. How do you get circumpolar stars? How is it that you can see Polaris from the northern hemisphere, however you cannot see it from the southern hemisphere?
Okay, so there's two parts to this. One, space is also very big, and also space is also, those objects are very far away. So in order for us to move away from them and with any normal change, we don't have to go a fuck of a long way. And here's the thing. The reason why they stay above the same part of the sky, and the reason why the southern celestial pole stays upon the same part of the sky, is because those stars are actually observable. If they're observable to the naked eye, that means they're inside the same Milky Way. If they're inside the same Milky Way with a one direction of rotation, as we know the Milky Way spins, would that mean that the stars are moving with us? Which means relative to our perspective, they wouldn't be moving? Holy shit, I think we figured it out, guys.
All right,
okay, so everything's magically being dragged. I mean, I don't know how that makes sense on a Big Bang at all, if everything's just perfectly locked in place and moving with us. Very interesting.
I disagree with your term drag, because if you're driving next to a car that's driving at the same speed as you, it's not moving relative to you. Are you dragging the other car along with you, or is it simply moving at the same speed of you at the same direction? The Milky Way is a plane of stars rotating around a celestial point.
A plane of stars? So planes are flat. So.
Yes, the Milky Way is a plane of stars. No, I'm not saying the sky is flat. I'm saying the Milky Way has a plane of stars.
Okay, but there's no parallax, so I think it's flat.
Oh, okay, what is parallax? Do you know what parallax is?
Yeah, it's measuring the distance of movement of stars away or towards Earth.
Not away or towards Earth.
Yeah,
that's not parallax.
Or their movement in relation to other stars. So all the constellations.
I'm
not really what parallax.
That's not parallax. Okay, let me rephrase the question. I can tell you what parallax is without bringing in stars or astronomy or anything like that. My challenge to you is to do the exact same thing. Tell me what parallax is without bringing in stars, suns, spaceships, or any of that shit.
Are you still with us there, Nathan?
Yeah, I'm here.
Oh, okay.
I don't know. So
Okay.
I don't claim to know everything. I'm
That's
here to
fine.
learn.
If
you guys
he's
teach
not
me
aware of
things,
it, Reg, do you want to explain to the
I'd
audience
love you
real
could teach
quick
me things.
what parallax
So
would
much,
be then?
All right, yeah, okay. Parallax is an effect where the position of a certain object seems to differ relative to the background objects based on your position to it. So, for example, if you hold your finger in front of your face and you look at its position relative to a spot on the wall with one eye, if you switch to the other eye, you'll see that its position changes relative to the object or the feature on your wall that's further away. That is what parallax is.
Exactly.
So have you heard of Halton Arp?
Halton
Yes.
Arp or
You mean the astronomer?
Yeah, the astronomer. They called him the modern Galileo. He used to work under Edwin Hubble as his assistant. Have you heard of him?
well, not very familiar with the name, but I'm sure I could be.
Okay. Yeah, well, while he was compiling a list of peculiar galaxies, he discovered that high redshift quasars are commonly associated with or even connected by filaments of lower redshift galaxies. Since the Big Bang requires that differences in redshift place the objects at different locations, astronomers commonly reject his claims, but if he's right, there's no Big Bang.
All right. Well,
So
I'll tell you what. That's a completely different topic. That's dealing with Big Bang. We can definitely have another topic, and I will get you another interlocutor.
Dealing with stars.
Well, hang on. Let me say this. The Big Bang is not the topic of the discussion. I would be happy to even do that debate with you. I think, or I can get somebody like Dr. Hugh Ross in, who's an astrophysicist, or we can get Landon Knoll, who's an astronomer. I think that's a completely different topic, but we would love to have that as a secondary follow-up with you, if that's okay.
Yeah, no, it's totally not my area of expertise. I'm all about verifiable, repeatable evidences that the Earth is flat and stationary. So that's why I jumped on this debate. I thought
it's just a different
that's
topic.
what I really.
Altogether. Yeah, and like I said, we'll be happy to get you other interlocutors for that because I think it's a little bit off topic from the shape of the Earth. The Big Bang has no relevancy to the actual shape of the Earth.
So wait. So on a globe Earth, how's a globe Earth created? I just would like Red. How do you think globe Earth was created?
Oh my God, accretion. Okay, so if you want me to go ahead and go into this, by the way, I just want to preface this by saying this has absolutely nothing to do with the original debate, but I will go ahead and answer that question. But you are going to have to listen to me ramble.
Yes.
Okay, so you had a batch of gas and dust that eventually, over millions and millions of years, collapsed in on itself under its own gravity. Towards the very center of that, you had a very dense collection of gas.
Where'd all those materials come from, Red? Please just start with that.
Let me finish.
I mean,
that was not part. That was not part of your original question. Are you going to rephrase the question?
How did globe Earth come into existence? Are you just saying that all the materials were just there in space?
I am going to answer that question, but it requires your participation in order for me to answer that question. And the way you're going to participate is to actually shut up and let me answer the question. So let me go ahead and try this one more time.
Yeah.
So again, you had a collection of gas and dust. That gas and dust eventually collapsed in on itself due to their mutual gravity. As you compress objects, you drive the temperature up. It is a simple law of chemistry. Eventually, that gas and dust collapsed into a dense enough sphere where fusion could occur. And then our star...
It's not what I was asking. I really don't even care at this point.
Hang on.
If you ask a question, you have to let the other person actual answer. He's allowed you to answer. Please allow him to answer.
He's starting with materials, okay? Where did all
Let
those
me
materials
finish,
come from?
please. If you want to rephrase the question after the fact, that's perfectly fine, but I'm going to answer your original question first.
That's cool.
So, after the star was made, what was left over was an accretion disk of also gas and dust. And the solar wind blew the gaseous material further out, leaving the more rocky material behind. These lumps of gas and dust eventually collapsed in on itself to form like 100 or so planetesimals. These planets fused in together to create bigger planets and bigger planets. Eventually, their gravity forced them into a state of hydrostatic equilibrium, which has the effect of having a rounded shape. Essentially, all that means is that once an object has a certain amount of mass on it, it will form itself into a sphere as a consequence of that, since that is the most stable shape to have with that amount of gravitational pull. And so after that, you had multiple planets. You had Mercury, Venus, Earth, and Mars, the rocky planets, Jupiter, Saturn, Uranus, Neptune, which were the gaseous planets, all form into spheres because of that is the state they have to be in order to be hydrostatic, in order to have hydrostatic equilibrium. It's the same effect for the Earth. So to answer your question, in a very simple way, the Earth acquired enough material so that its gravity can force its shape into a state of hydrostatic equilibrium with the effect of having a rounded shape.
Does that answer your question, Nathan?
Yes, the gravity god did it. The one that's never been proven. Mass attracting mass has never been proven. I already told you that attraction should be stronger the closer things get to Earth, and that's not what we, not what visible. Gravity did it. I counted the number of times you said gravity a bunch of times. So gravity does everything, even though we can't prove it, and that's how the Earth was created.
I want to make sure I get this right. Nathan, did you just say that mass does not attract mass?
That's never been proven correct. Yeah, all objects with mass are not attracted to other objects with mass.
Hashtag Cavendish experiment. So let's go.
Have you repeated that?
Actually, yes, I have.
Yeah, I think it's been
FSU is a place. And also, going on from here, I have a follow-up question to that.
Okay.
Why do you think I have an original question and a follow-up question to that, if that's okay.
So whatever you want. You can ask one question. That's fair. But go ahead.
Okay.
And you
so here's my question. It has been asserted by flat earthers that the reason why objects fall is because of density. We're denser than the air around us. So essentially the air is the gravitational, or not the gravitational, but the pressure. The air is the influence that forces objects to fall towards the ground. If we were to put objects in a vacuum and get rid of the air, therefore getting rid of that directional influence, why do objects still fall?
Because you picked it up and dropped it, Red. Okay?
Perfect.
So.
Cool. That totally answers my question.
The Earth isn't spinning, so there's no magical force that needs to bring things down towards Earth. You pick something up, you let it go. If it's not a helium balloon, I don't understand.
So your answer is it falls just because.
No, it falls because you dropped it. Okay, but not everything falls.
So just because.
Get a helium balloon and let go of that. That doesn't fall.
Here's the thing. If a helium balloon could actually survive the internal pressures of a vacuum, then actually, yes, it fucking would.
Are you using the same definition of density as he is? I'm just going to clarify that. I want to make sure that Nathan's using the word density the same way you are as mass over volume or unit volume.
I hope so, but in reality, it breaks away from my original question. I asked why things would fall in a vacuum if we get
Why wouldn't they? You removed the air particles. All you did was remove air particles from under the object.
Because the assertion.
Air particles,
the reason why is
magically make things float or magically make things fly away from a flat Earth. Like, I don't understand what you think would happen. Boats disappear bottom first. Objects fall, even if you remove the air particles underneath them. I mean, it's pretty basic stuff. I don't.
Yeah, the confusion is twofold, because if flat earthers are the ones asserting that atmosphere actually makes the directional influence and we get rid of the directional influence, then yes, you actually do need to explain why objects fall when you get rid of the directional influence that you assert is the only directional influence on the actual fucking object. So yes, I too am confused. So if your answer to that question is because you dropped it, I'm pretty sure you not only answered that question, but a bunch of others that other people have had in the live chat.
So if you had two objects in a vacuum and they had really strong gravities, would they orbit or would they collide?
Two objects in a vacuum. You're talking about in space, in nothing space, right?
So yeah, just like the galaxy, right? I mean, if you had a bunch of big objects in space, and obviously the Earth's big enough to have a gravity, right? I mean, everything in space has gravity. Why aren't they attracted to it? Like when you say things fall in a vacuum, the gravity of Earth attracts it, and then it gets stuck to Earth on the ground. So why
basically,
aren't any planets stuck to Earth on the ground.